Hi, welcome to the workshop on Popper. Essentially what we're doing here is using the ideas of Popper to help us critically analyse a paper or a piece of research. Now, the homework I gave you to do was to state a theory, possibly a theory you'll be testing in your own project, if not something else. So just to limber up with, could you tell the person next to you what the theory is that you've written down? Okay, so sort of keep that theory in mind, because that'll be your example you'll be working with as I go through some examples here. And we'll be considering the following principles. That Popper said, if it's good science, it'll involve a substantial theory being put up to test, some safe background knowledge to crack it against, a test that's severe, and of course possible outcomes that could refute the theory that you've stated in the context of the experiment you're going to perform or that you're looking at. So let's go through those in turn. First of all, can you isolate a substantial theory that's being put up to test? Now, one distinction to make here, which isn't exactly Popper's terms, but gets at something close to what he was talking about, is the difference between a substantial theory and a statistical hypothesis. So if you said, I wonder which of these variables will influence reaction time, you have a whole bunch of variables. There's no substantial theory there, but there's a bunch of statistical hypotheses. But if you said something like, I think exposure to adversity makes people resilient, well, that's a substantial theory. Now, when you have a substantial theory and you're going to test it, you will in the end convert it into something like a statistical hypothesis. Like, in order to test exposure to adversity makes people resilient, you might measure resilience by, say, measuring calmness on a 7-point scale while people taking exams. And then you see if that correlates with Sprig's life adversity scale. And that's a statistical hypothesis. So the difference is a substantial theory mentions the psychological constructs of interest, might even mention a mechanism that links those things together. And a statistical hypothesis will mention particular dependent variables, particular independent variables, and really the population from which you're drawing. Although the population is normally not specified exactly and is sort of implicit, it's sort of defined by the participants section. How did you select these participants? Well, whatever population you could regard them as being randomly drawn from is the population. So the difference is a substantial theory can be tested in lots of different ways. So exposure to adversity makes people resilient. There's all sorts of ways of testing that. You don't have to use Sprig's life adversity scale, which I just made up, by the way. You don't have to measure resilience by calmness on a 7-point scale during an exam. Right? So there's all sorts of ways of testing the substantial theory. The way Popper put it was what you're looking for is a bold theory. You want to make your theories as bold as possible. And the substantial theory is going to be something that's reasonably bold, and a statistical hypothesis is going to be something that's not that bold, because it's being very, very specific. So now, just as a quick check, tell the person next to you the theory that you just stated, was that more like a statistical hypothesis or more like a substantial theory? Just tell the person next to you. Or just hands up if you understand the distinction between a substantial theory and a statistical hypothesis. Is that clear? Great, good. So both can be testable, although we'll see not all statistical hypotheses are actually as testable as you might think. a point we'll come to later. So as long as there's something testable or falsifiable on the table, we're in the business of science. But what we would really like is a substantial theory for better science. Because science isn't black and white. There's sort of degrees of falsifiability, according to Popper, and therefore degrees of being good science. Consider this experiment. I flash up, let's say, achievement words. So it could be words like success, victory, gold, something like that. Or in another condition, control words. And I see how long people persist with a crossword. So what would be, what could have been the substantial theory that's being tested here? Which would you like to take as a substantial theory? Could be priming with achievement words makes people work harder on crosswords. Or priming people with the concept of achievement makes them work harder on tasks. Let's say you get the result that was wanted here, that flashing up the achievement versus the control words did make people persist more on the crosswords. What theory would you be prone to claim at the end of this had been supported by the data? Would you have a preference for either of these, or you wouldn't mind? Just tell the person next to you what you think. As I said, Popper's advice was to make your theory as bold as possible. So in this little example here, one of these versions is a little bit more bold than the other. Namely, the second version there is bolder than the first in Popper's sense, in that there's more different ways of falsifying it. It's more falsifiable. So priming people with the concept of achievement makes them work harder on tasks. That could be falsified not just with crosswords, but with any task you want to come up with. And the priming doesn't have to be with words. The priming could be, I don't know, seeing a video of people achieving things, or something like that. So the second version here can be falsified in more different ways than the first. It's more falsifiable, it's a bolder theory. So from Popper's perspective, that's the one you'd want to go with. You're trying to be as bold as possible in your science. You're not trying to stick to the data as much as possible. You're trying to say something interesting. So when you're looking over a paper or thinking about your own research, if you're following Popper's advice, think about what's the boldest form that you could state your theory in a way that's not yet falsified. You don't want to state a falsified version. But what version could you state that isn't yet contradicted by the data that's as bold as possible? And when you're trying to extract the theory from a paper, think about what's the boldest or most falsifiable version I could give this, state this theory, and that's being tested by this paper. So just have a little think now of the theory that you stated. Is there a bolder way of stating it to make it more interesting, more falsifiable than what you just said? Just have a little think about that, the person next to you. Okay, so note in this case, by the way, these are both substantial theories of a sort, but one is a bit more boring than the other. And sort of the one end of boringness, if you like, is a statistical hypothesis. And the other end would be a very general, bold theory. So that was Popper's term, was sort of boldness, by which he meant falsifiability. And I've sort of converted that into psychological terminology for statistical hypothesis versus substantial theory. But the boldness idea is more general. So the principle here, which is kind of obvious, Popper said good science involves falsifiability. If you want to summarize POP in one word, it's good science is falsifiability. But to implement the criterion of falsifiability, obviously you have to say what theory is falsifiable. So when you come to writing your essay, make sure you have a clear statement. This is the theory that's being put up to test. Or else you argue there isn't one. But say something one way or the other. So now the second point is, having identified some theory that is being put up to the test, in order to test it, you need safe background knowledge. So some philosophers use the term auxiliary hypotheses here. Popper used the term background knowledge. The point is, a substantial theory makes predictions by using auxiliary hypotheses. So you just stated say a substantial theory to the person next to you, and then there's some experiment that's going to test it. But somehow you need to connect the theory to the experiment. So take the theory that experience of adversity in life creates later resilience. You could have a manipulation where you try and give people adversity. They have a boot camp on the Downs, and they have to find different locations, different pubs or valleys or whatever. So they're given a map and some instructions. And one group is given an easy task where the instructions are really easy to follow and they'll just do it, no trouble. And in the other case, the instructions are designed to lead you into obstacles and difficulties that you'll have to work your way around. So it will meant to create some adversity. Let's say you control the total amount of walking that would be involved. So you have some manipulation of adversity, you claim, and you have some measure of resilience, later resilience, say calmness during an exam. And you say, this is how I'm going to test the substantial theory. But certain assumptions are made in using this as a test of the substantial theory. And those assumptions are called the auxiliary hypotheses. Or Popper called it, it's your background knowledge that you're using. So what are the auxiliary hypotheses in this case? Well, in general, you always have to assume the dependent variable measures the thing that you claim it measures. So the claim is that calmness during an exam measures resilience. The claim is that this manipulation here manipulates adversity. Those are assumptions you'd have to make in order for this experiment to test the substantial theory. So those are amongst the auxiliary hypotheses that you have to have. So the dependent variable measures what it says it measures, the independent variable manipulates what it says it manipulates. It manipulates it in an unconfounded or pure way. So the auxiliary hypotheses are the things you have to assume to be true for the study to test the substantial theory. So, for example, calmness in an exam measures resilience. Is it safe? Is that a safe assumption to make? Do we really think that? See, if you found that debatable, if the experiment seemed to go against the theory, you could say, no, that experiment doesn't go against the theory. The dependent variable was a bad dependent variable. I'm not going to give up my theory. Instead, I'm going to reject the assumption that the dependent variable measured resilience. You see? So the experiment wouldn't be testing the theory if you argued the dependent variable did not measure the thing it was meant to measure. In this case, it did not measure resilience. Similarly, this sort of boot camp on the Downs, does this really manipulate adversity in a pure way? You could imagine, for example, that maybe not a lot of adversity was really involved in either case. Depends how well they've set up this manipulation. For there to be adversity, there needs to be some stress. There needs to be definitive obstacles that appear difficult to overcome. Has that really been achieved? So in any study, you need to critically evaluate the auxiliaries. So you might want to measure the extent to which one of these groups of conditions actually involved obstacles that appear difficult to be overcome. So in papers, this is often called norming studies or manipulation checks, something like that. Did you really change the thing or manipulate the thing that you claim you're manipulating? I mean, just because you call a questionnaire a measure of resilience or whatever doesn't mean it is, right? Just because some authors claim it is, it doesn't mean it is. Now, one thing you might argue is, well, I didn't do any manipulation check, but look, we did do the manipulation, this summer camp, boot camp we'd set up, and it did change the calmness in exams in a predicted way, so the manipulation must have worked. We got the predicted results, so although I didn't do any manipulation check or any norming or anything, the counts must have differed in the right way. What do you think of this way of reasoning? Do you think that's acceptable? You see it commonly, and it is sort of enticing to think that way of one's experiment. You got the results you wanted, so everything must have been okay. But if the experiment had not confirmed the prediction, you could have blamed the auxiliary. So that's why this isn't an acceptable way of reasoning. Because in effect, it renders the theory unfalsifiable. Because if you got the results you want, you say, there you go, the experiment worked, the manipulation must have done what it said it was set out to do. But if it didn't work, you could have said, yeah, but I'm not going to give up my theory because probably the manipulation didn't really change adversity much. So in no set of results do you ever give up your theory or even use the results to count against your theory. So it never was a test of your theory, you see. So that's why what you need is a manipulation check, or what might be called an outcome neutral test. The outcome neutral test in this case would be checking that the manipulation of adversity actually changed adversity. It's neutral about whether the theory is right about resilience, but it's checking whether the independent variable manipulated the thing it claimed it manipulated, namely in this case adversity. It's a check that the independent variable does what it says it does. Because it's only if it does what it says it does that you have a test of your substantial theory. So now, what I'd like you to do is, with respect to the theory that you've been talking about with your partner, think about some of the auxiliary assumptions that could be involved in a test, or is involved if you already know what the experiment is. Some of the auxiliary assumptions that are involved. In other words, the things that you have to assume to be true for the test to actually test the substantial theory. Okay, so auxiliaries are the sorts of things that often make up the meat of the discussion, or even sometimes the method section of papers. They ask whether their variables are reliable or valid, whether there are confounds, and so on. And all that sort of discussion is a discussion of the auxiliaries. Notice that an auxiliary can't be any part of the substantial theory itself, though. Because the auxiliaries are the things you're going to take as true in order to possibly falsify the substantial theory. So the auxiliaries are something other than the substantial theory. The dependent variable measure, claiming the dependent variable, assuming or testing and then assuming that the dependent variable measures resilience, is not assuming that the substantial theory is true. It's just assuming we have a good measure of resilience so we can test it. So this is sort of setting out some of these concepts here. You have a substantial theory, which may have been motivated by a number of other theories and findings. Often this stuff is what's in the introduction of a paper. It might mention all sorts of theories that's motivating the theory tested here, but these other theories aren't themselves being tested. For example, it might mention the theory of evolution. I'm willing to bet no paper that you read could have a possible conclusion, and therefore the theory of evolution is wrong. It might have been motivated by the theory of evolution, but it's not testing it. Or it might take terror management theory or dissonance theory, but it probably won't conclude that dissonance theory is wrong. It might do, but it probably won't conclude that dissonance theory is wrong. So those sort of very general theories are simply serving to motivate the substantial theory. So the substantial theory is the broadest theory that could be shown wrong by that experiment. It's the broadest theory in which you could say, but that can't be right if I get this pattern of results. So when you're reading a paper or considering your own project, you want to disentangle the broad ideas that motivate your particular theory and the actual theory that you're putting up to test. What is it that you could give up given certain results in your experiment? Then you use your substantial theory to make predictions, which would be in the form of statistical hypotheses. But you can only make these predictions by assuming certain things, and these are the auxiliary hypotheses. Like, as I say, the variables measure the things they say they measure, they're reliable and valid, there aren't any confounds, and so on. Other auxiliary hypotheses will be things like the data are distributed in the way assumed by the statistical test. It's everything you need to assume for the test to test the substantial theory. So then, if you get a certain set of results, there must be possible results that are falsifying. So that if you get a possible falsifying observation, that falsifies the prediction. And then, because the auxiliary assumptions are false, you say that falsifies the substantial theory, or at least counts against it. But you see, if one of the auxiliaries was a bit dubious, this falsification of the prediction could be used to challenge the auxiliary, and the substantial theory is thereby protected from being falsified, refuted. So that's why you want your auxiliaries to be safe, so the falsification is transmitted back to the substantial theory. That's the function of safe auxiliaries. You say, yes, I claimed in advance that these variables do measure what they say they measure. I said that is adversity, and I said that is resilience. Adversity made people less resilient, so the theory as stated is wrong. I'll give it up. Then you have a proper test, because you would give up your theory. But if you say it looks like that adversity decreases resilience, you might say, no, I'm not going to accept that. That dependent variable, no way was that resilience. I'm keeping my theory, thank you very much. And so the falsification is not transmitted back to the theory. You're protecting yourself. So in order for the experiment to test your theory, we need to make some assumptions, and those are the auxiliary hypotheses. Now when it comes to writing your answer, because these auxiliaries sort of go on and on, there's not some fixed number of them, just show you understand the concept by talking about 2 or 3 of them. You don't have to endlessly list them. Once you've shown you understand the concept, that's fine. Just put your hands up if you understand the notion of an auxiliary hypothesis. Does that make sense? Excellent. So the point is here, to implement the criterion of falsifiability, you need to accept some things as given in order to falsify something else. And of course, the process of accepting some things as given may involve further tests. It might involve norming studies, testing that the manipulation of adversity creates adversity, and so on. So this might involve a bit of work, but there comes a point when you say, we've tested it enough, I do accept the auxiliaries. So your job in looking at the paper and writing this essay is just to make an honest judgment. I don't have any preconception about whether the auxiliaries will be reasonably safe or not. You're just saying, for the purposes of this experiment, are these auxiliaries safe enough that in fact I would give up substantial theory if the results came out that way. All right, so the next notion is what Popper calls test severity. And a test is severe if other established theories do not make the same prediction. And let me go through what this means and why it's important. All of this will be up on the Study Direct site, by the way, podcast and PowerPoints. So let's say we have the theory that if you expose people incidentally to goal-related concepts, like they read words to do with achievement, it'll activate those goals, for example, give them an achievement goal. So that's the substantial theory, goal priming. If you come across the concept of a goal, you somehow take on board that goal as your own. At least you have a tendency to do so. So you say, okay, what I'm going to do is I'm going to show people some achievement words. We'll flash up victory, gold medal, and so on, or control words on different days, and we see if they work harder on a crossword after the achievement words. This will be the test. So what a test being severe means is that the prediction needs to be unlikely on other established theories. In other words, there's no other established theory that would predict the same results. So is there another theory that would predict these results? Well, let me give you a theory that applies in a lot of experiments. Just crops up a lot in psychology. So you see what I mean, and it could well be one that's relevant to the experiment that you're thinking about, or you're going to write about. That's the issue of demand characteristics. So let's say I'm a subject, and I notice that in one condition the words are all to do with success, and in another condition they're not, and I'm giving a crossword to do, I might say, well, I know what this experimenter wants. He wants me to work harder after I've been flashed up words to do with working hard and achieving things. In other words, the subject might work out what your theory is. And subjects often like to be helpful in inverted quotes, and give you what you want, because they're nice. So they work harder after the achievement words, just because they think that's what will make you happy, and that's what they as a good subject should do. So that's what's called demand characteristics. So if the point of your experiment was kind of obvious to subjects, and subjects could give you, it's within their power to give you results that will be consistent with that theory, then the results are kind of likely even if the theory is false. Right? Even if your theory were false, you'd probably still get supporting results if there's strong demand characteristics to get those results. You see what I mean? So that issue of demand characteristics will crop up a lot in psychology experiments and forms a general sort of alternative explanation of a lot of possible experiments. So now, the issue here, it's slightly different from the auxiliaries I talked about, because the falsification would still transmit back to the theory. The issue here is, even if the theory were false, you would be unlikely to falsify it. Because even if the theory were false, subjects are going to give you what you want, and you're going to get supporting results. We expect the same results whether or not the theory is true. And that's why it's not a good test or a severe test of your theory. So if there's some other mechanism or reason why you would get the predicted results, then you don't have a good test of your theory. Because even if the theory is wrong, you're still going to get apparently supporting results. Or to sort of use one of Popper's phrasings, to implement the criterion of falsifiability, the theory must be made to stick its neck out. The theory hasn't been made to stick its neck out if it's highly likely you'll get supporting results no matter what. That's not sticking its neck out. Sticking its neck out means you've got to say, my God, if this theory passes this test, that would be amazing. Just put your hands up if you understand the notion of a severe test. Does that make sense? Okay, great. So now what I'd like you to do is to think about the substantial theory that you started with, the test that you're hypothetically considering, and just consider, is it a severe test? Or is there some other explanation, some other mechanism, some other theory that could make the same prediction in the context of that experiment? Okay, so in a way, Popper, one of the criticisms of Popper is he often comes across as very black and white. You have to decide, are the auxiliaries or your background knowledge, is it safe, yes or no? And the reason is, if you want to come to a decision that this experiment did refute that theory, you do need to decide whether some auxiliary is safe enough. Not that it's 100% safe and you're completely certain of it, Popper never required that, but just, are you going to accept it? Is it safe enough for the purposes to which you're putting it? And Popper didn't regard science as black and white, either scientific or not scientific. Any given experiment or theory has degrees of falsifiability, and any given auxiliary will have degrees of safeness, as it were. So you can think about what Popper is talking about as an ideal to which you strive. Yes, we would like the auxiliaries to be black and white 100%, and in a way, it's only by assuming that that is the ideal to which we strive that we can make sense of what scientists are doing in the discussion sections and why they tighten up the methodology or in this or that way. But you're quite welcome to come to a shade of grey conclusion. You can say, I think, well, these auxiliaries do seem safe enough to me, but this one really could be tested a bit further before I'd be willing to make a firm conclusion. Now, obviously, if you're going to have a falsifiable theory, you need possible falsifying outcomes. But it is instructive and useful for you to think about and to specify what outcomes precisely would lead you to give up the theory. And that would be a very useful thing to do for your project before you run your project. Think about what outcomes would lead me to give up my theory. Now, to be doing this sort of Popperian science, it doesn't have to be quantitative, it could be qualitative. It doesn't have to be significance testing. As long as there's some observations you could make that you'd say would change your mind about a theory and say, no, that theory doesn't look right, it's got to be another one, well, then we're in Popperian business. So let me go through some examples to see. This isn't quite as straightforward as you may have been led to believe by reading the literature in psychology. So let's say we have a theory that predicts men and women should be the same on a task. So we have some dependent variable. Let's assume the auxiliaries are all safe, and so I'm not talking about that. So what pattern of significant and non-significant results would refute this theory here? Just tell the person next to you, what pattern of significant or non-significant results would refute the theory that predicts men and women would be the same on the task? Okay, so here's a simple answer. What I was looking for is significant difference in any direction. Okay. There'll be sufficient grounds to say, no, that theory's not right. Okay. The theory says it's the same, but if men were significantly better than women, or women significantly better than men, then you would say we need a different theory. All right. How about if a theory predicts that women should outperform men on a task? Tell the person next to you what would refute that theory. All right, so what would work here is a significant difference in the wrong direction. That would refute the theory. But a non-significant result would not refute the theory. So you might be tempted to say no difference. But what grounds do you have for saying there's no difference in the population? Not a non-significant result. So I'll come to that to explain that, because that's where you've probably been misled by the literature. In terms of conventional significance testing, the only thing that would refute this is a significant difference in the wrong direction. So what about if the theory predicts that men and women should perform differently? It says, I don't care about the direction, just I think men and women will be different. There will be a difference. That's what the theory says. What would refute that theory? Just discuss that with the person next to you. So the crucial thing here that's somehow hard for people to get their head around, because everything you read implies the opposite. A non-significant difference in itself falsifies nothing at all. That's the point I want you to understand. A non-significant difference is not grounds for saying there's no difference in the population. When Fisher invented significance tests in the 1920s, 30s, he was very clear about this. He said no conclusion follows from a non-significant result. In Fisher's terms, you suspend judgment. Okay. You can get evidence for no difference, but only if you're a Bayesian. In terms of significance testing, you're not going to get it from non-significance. So let me try and give a brief explanation about that. It's true that a non-significant result is consistent with the null hypothesis. You haven't rejected the null hypothesis of no difference, chance performance, and so on. So when you get a non-significant result, it's consistent with there being no difference there. In other words, you're meant to still entertain the possibility of no difference. That's what a non-significant result means. Entertain the possibility of no difference. But it's also and always consistent with some difference. A non-significant result is always consistent with there being some difference there as well. It's just that it's consistent with no difference and it's consistent with some difference. In other words, it's consistent with the null hypothesis, but it's also consistent with the alternative hypothesis. It's consistent with the null hypothesis and it's consistent with your theory. So a non-significant result in itself gives you no grounds for favouring one of those two theories over the other. So if it gives you no grounds in itself, because it's consistent with both the theories, the null and the alternative, you shouldn't choose between them just because you have a non-significant result. That's why it sort of counts for nothing, as it were. Now, it may very well be, given certain assumptions, your data do provide evidence for no difference, but you'd have to do some other test, namely a Bayes factor, in order to find that out. So a non-significant result in itself does not support the null hypothesis. So that's why don't use the non-significant result in your arguments for what counts against the theory. If the paper you're considering just did conventional significance testing, it's only possible significant results that can be used as evidence or as grounds for going against a theory. Okay. And that's something to think about in everything you do in psychology or any other discipline that uses inferential statistics. And the reason why it's difficult is probably every paper you read and every talk you go to uses non-significant results to assert no difference, no interaction, chance performance, and so on. So you're constantly misled in this way. So you're going to have to be vigilant and change habits in your mind and not take for granted things that you read in order to really take this on board. 10 years' time will be different. The literature will have been transformed. But at the moment, you're in a process of coming into a literature before it's been fully changed. So this is the point here, kind of obvious. To implement the criterion of falsifiability, it must be possible to obtain falsifying results. So what you need to say, and actually, although that sounds kind of trivial, but it really is instructive to write down and say, yeah, for this substantial theory here, I would give it up with this precise pattern of results. Try it yourself and see. It's not actually as straightforward as you might think, in many cases anyway. At least to know that that substantial theory is testable, you better be able to say, these are the conditions under which I would give it up, and I get precisely these results. So to summarize, and this could in some way form the structure of your essay, but it need not. I'm just giving you some possibilities and some things worth thinking about here. The test is a good one, and the paper contributes to good science to the extent that it has some explicit substantial theory that's put its neck out by having safe background knowledge in constructing the test, which is severe because the predicted outcome is unlikely given other theories, and you can state actual precise results that would lead you to give up the theory. Now, a given paper may not sort of satisfy all those criteria, but that doesn't mean that it doesn't contribute to science. So, for example, what it might do is it might be a little bit exploratory, and it hasn't really tested a theory, but it helped generate a theory that could be tested. So it's still contributing to the scientific process. I mean, any given paper can only go so far, right? Can only do so much. So a paper can contribute to science, even if it doesn't do everything in itself. It could have been a useful step in this. It might contribute that although the paper had some unsafe auxiliaries, it laid the groundwork for another study that could have safer auxiliaries. So you wouldn't want to say this paper is nonsense just because there's some problems with it. It might have been a definite contribution to the scientific process. So I don't feel you have to come to some black and white decision here. You want to argue how well it does contribute and what were the strengths and weaknesses. So that's all I want to say about it. So what I'll do now is I'll just go around and see if there's any more questions and deal with any of your questions, but you're free to go whenever you wish. Thanks.